Okay, in this video we're going to talk about how to solve radical equations. It's pretty simple when it comes down to it. You've already known how to solve equations since like middle school. This only has the extra added benefit of having to deal with square roots in our equation. And it's pretty straightforward, but let's get into it and I'll show you just a few examples and hopefully you get the idea. Alright, so here I'm looking at the square root of x equals 5. Now before actually doing any mathematical operation on this problem, you can probably answer it yourself. The square root of something is 25. Well, the square root of what is, the square root of what is 5? I've already given it away. The square root of 25 equals 5. So that must mean x is 25. Well, let's see how we get that answer. Now, you know if I'm multiplying something on the left, I would get rid of it by dividing it, right? If I was adding something to the left, I would get rid of it by subtracting it, right? Alright, well, what if I'm square rooting something on the left? I can get rid of it by, fill in the blank here. Well, what's the opposite of the square root? Well, squaring, right? Squaring something, what I mean by squaring something like something to like a power like 5 squared, is the opposite of square rooting something. Alright, so essentially a square root and a square cancel each other out. So if I'm square rooting x, I can get rid of that square root by squaring the square root of x. But of course, if I do it to the left side, I have to do it to the right side. So that simply removes the radical sign and leaves me with just x. And of course, on the right-hand side, 5 squared is going to become 25. So we solve the equation x equals 25. A point to mention here is when I square that square root, I'm not touching the x, I'm not doing anything with the x or anything inside the square root. All the stuff that's inside the square root will be unaffected. All it simply does is remove the square root sign, okay, and leaves whatever's under there just simply there, but without the square root. Alright, let's take a look at another example. Alright, so 10 equals the square root of 2x. Now, there are multiple things I have to do here. Notice the right-hand side is where all my attention is going to go. The 10 doesn't have the x on it or a square root, so I'm not really concerned with it. But the right-hand side has my x, it's got my square root sign, so let's focus on the right-hand side. Now, if I want to get this x by itself on the right side, I'm going to have to remove this 2, and I'm going to have to remove the square root sign. So I'll have to divide by 2 to get rid of 2, since I'm multiplying into x, and I'll have to square the right side so I can remove the square root sign. But of course, what do I do first? Because that's the issue here is, if I don't do this in the correct order, I'm going to be wrong. So here's kind of how you go about it. If it's inside the square root sign, then it's pretty much locked up in a safe. I can't really access 2x as it's in that safe. I have to open it up first before I can access it. So it's trapped underneath the square root sign, which means I'm going to have to remove the square root sign in order to get inside here. So it means I'm not going to divide by 2. I can't do that yet because the square root is in my way. So I'll go ahead and I'll get rid of the square root first. And of course, I just mentioned, if I want to get rid of the square root sign, I have to square it. That's the opposite operation of a square root. That's what's going to cancel it out. But of course, if I do that to the right side, I have to do it to the left as well. So the left 10 squared would give me 100. And on the right, squaring a square root will just simply get rid of the square root and leave me with 2x. Remember, it does not affect what's inside the square root. It simply removes the radical sign. And of course, now I can divide by 2. I'm multiplying 2 to x. I'm going to divide it to get rid of the 2 and leave me with just x equal to 100 divided by 2, which is 50. And if you ever in doubt if that was the correct answer, you could plug it in and see if it works. So the equation with 10 equals the square root of 2 times x, but x is 50. So 10 equals the square root of 2 times 50, but that is 100. The square root of 100 is 10, so of course 10 equals 10. It does indeed pan out. So plug in your answer and see that it works, and you can make sure that you're correct. Okay? So it's a good way of checking your answer. Alright, so again, focus your attention on the side with the square root side of the x variable. That side is the left side, so don't really pay any attention to the 5 right now. Everything I mentioned is kind of the 5 is irrelevant. We'll move things over towards that 5, but we won't touch the 5 itself. Alright, so here's my general rule of thumb, because we have a couple things to do here. We have to square my square root, and we have to get rid of this 4 at some point. But again, the importance is what I do first, the order in which I solve this. And here's my general outline. My general outline is, let's find anything that is outside the radical, and let's take care of that first. So anything you see outside the radical, let's deal with it first. Once I've taken care of anything that's outside the radical, or all things that are outside the radical, then I'm going to take care of the radical itself. Okay? And that's the part where I square my square root. That's simply where that comes into play. And then the last thing I'll do, once I've done the radical, squared my square root, then I'll deal with what was inside the radical. Okay? So let's follow this thought process. Let's find anything that's outside the radical sign. So my radical is here, square root of x. This minus 4 is on the outside. So I'm going to have to take care of this minus 4 first. And just like anything else, if I'm subtracting 4 and I want to remove that, I will have to add 4 to remove it. But of course, if I do that to the left, I have to do it to the right. So that'll leave me with just the square root of x equal to 9. So now, there's nothing outside the radical anymore, right? It's just the radical. So now I'll move on and I'll remove my radical. So I'll square this, but of course I do it to the left, I have to do it to the right. Now I'll take care of this and leave me with just x equal to 81. Alright? And again, you can plug that in and see that it works. Square root of 81 minus 4 equals 5. Square root of 81 is 9. 9 minus 4 equals 5. That is correct. 5 equals 5. Alright? So here we are again. Again, don't focus on the 7. Focus on the side of the x. So that's the left-hand side. So again, we'll go with what's outside the radical. Then we'll go with the radical, and then we'll focus on what's inside. Okay? So on the left-hand side, is there anything that's outside the radical? No, there isn't. And if you're thinking 7 is outside the radical, well, you're not wrong. However, you're focused on the wrong side. We're looking at just the side, okay, the left-hand side here of this equation, where my radical sign is. And on that side of the equation, there's nothing that's outside the radical, so there's nothing for me to do in that step. So that means let's go ahead and take care of the radical. If I want to remove my radical as anything else in all these problems, I will square it. That will remove the radical, but of course if I do it to the left, I have to do it to the right. So this leaves me with x plus 3 equal to 49. Right, 7 squared is 49. Again, just a reminder, when I square my square root, it does not affect anything that's inside the square root. All that stuff is untouched. It stays the same, but it simply does not have a square root sign anymore. So if I want to solve for this x, now all I need to do is focus on what was inside the radical, which is that plus 3. So I'll have to subtract 3 to get rid of it. X will equal 46. Again, you can plug that in and see that it works. The square root of 46 plus 3 equals 7. That's the square root of 49 equals 7. And of course that's true, 7. Square root of 49 is 7. Alright, so the square root of 5x plus 1 plus 6 equals 10. Keep in mind, this plus 1 and this plus 6, I cannot combine them, although they do seem to be like terms. The plus 1 is inside my radical, and my plus 6 is outside my radical. For that reason, I can't put them together. They both have to be in the same place, essentially. But your attention should be on the left-hand side, because that's the side with the x variable. And again, follow my process. What is outside the radical? Well, on the left-hand side, 5x plus 1 is inside the radical, but plus 6 is outside the radical. So that tells me, let's take care of this plus 6 first. If I want to move plus 6, I will subtract 6. It's the opposite operation. It will make it disappear, leaving me with just the square root of 5x plus 1 equal to 4. Now be careful when you write the radical sign, because some people get lazy and they'll write their radical signs kind of short. And it starts to look like maybe something's not inside of it, but if plus 1's inside of it, make sure you cover it all up. Okay, that's just keeping your handwriting neat so you don't get lost or confused halfway through the problem. Alright, so now, again, is there anything else outside the radical? Well, 5x plus 1 is inside the radical. There's nothing left outside the radical, so let's go ahead and take care of the radical now. So again, to remove my radical sign, I will square it. And I'll do that to both sides. For balance, we'll have 5x plus 1 without the radical sign now equal to 16. So again, I squared this side, I've removed the square root sign, so now I have 5x plus 1, no longer in a square root. And now I'll solve what was inside the radical, which, at this point, is a regular equation. So subtract 1, we'll have 5x equal to 15. Dividing by 5, we will have x equal to 3. Alright, again, if you're ever curious, you can always plug it in to see that it works. The square root of 5 times 3 plus 1 plus 6 equal to 10. Well, that would be the square root of 15 plus 1 plus 6 equal to 10. Square root of 15 plus 1 is 16. This is me just plugging it in the check. You don't have to do this, but it is kind of good. Square root of 16 is 4, and 4 plus 6 equals 10. That's true. So, again, that's just me plugging it in to see that it works. Okay? Alright, ignore the fact that says method 1 here. Follow the same rules as we've done already, okay? Look for anything that's outside the radical. Step 1. So on the left-hand side, that's where my attention is because that's where the x is. Okay? On the left-hand side, is there anything that's outside the radical? X is inside the radical, but 4 is outside. So that means I will have to remove this 4 first. Now, what am I doing with 4? That's key here. This is where another mistake comes in. 4, it's 4 times the square root of x, right? So if I want to remove 4 times the square root of x, I'll have to divide this 4. That's key. Make sure you do this to both sides. Simply because a lot of people sometimes will think that, they'll subtract it because they think it's a positive 4. It is true, it is positive 4. But it's not being added or subtracted to that square root. It's being multiplied onto this side. So we want to make sure we divide it to correctly remove it. This will leave me with the square root of x equal to 8. Right? And now there's nothing left outside the radical, so let's take care of the radical itself. So I'll square the radical to remove it, and I'll have x equal to 64. There's nothing left to do. I have my answer. Alright, again, you can plug it in to see that it does work. I'm going to go ahead and skip that for now. Alright, again, ignore the fact of method 1. But focus on the side of the x value. So the x variable is on the right-hand side, so let's focus our attention over here on the right-hand side. Okay? Now again, follow the same process outside. Look on the right-hand side for anything that's outside the square root. Well, I have my square root here, and x is on the inside of it. However, this 2 is not inside the square root. The 2 is on the outside, so we're going to have to remove this 2. So now we ask ourselves, well, what are we doing with 2? What's going on over there? Well, it's on the bottom. It's clearly being divided, right? This side is we're dividing by 2. So that means if I want to remove it, I'll have to multiply by 2. If I multiply this side by 2, that's the opposite of dividing by 2, and I'll get rid of it. Let's make sure we do it to the left side as well. This leaves me with 12 equals the square root of x. Now, there's nothing left outside the radical, so now we'll go ahead and take care of our radical. So we'll square this, and we'll have 144, 12 squared is 144, equals to x. But again, all of these problems, look for what's outside the radical. If there's anything there, go ahead and take care of it. Identify what's going on, and do the opposite. So if you're multiplying by a number, make sure you divide it to get rid of it. If you're dividing by a number, then multiply it to get rid of it. Same thing goes for adding or subtracting. Do the opposite of what you notice there. So on this equation, again, the x is on the left side. Let's focus our attention there. And let's find anything that's outside our radical. Alright, well, I noticed two things. The 2 is on the outside of my radical, and this 5 is on the outside of the radical. Let's take care of both of those. I don't like fractions. I'm going to go ahead and get rid of this 5 first. Now, I'm dividing by 5, which means I have to do the opposite of dividing by 5, which is to multiply by 5. Now, we'll remove it and leave me with 2 square root of x equal to 20. 4 times 5 equals 20. All right, I still have this 2. This 2 is still on the outside of the radical. I still need to get rid of it. And again, it's being multiplied to the square root of x. So if I'm multiplying 2, I'll get rid of it by dividing by 2. The square root of x equals to 10. And now, there's nothing left outside my radical, so I'm going to take care of the radical now. I'll square my radical to remove the square root, and I'll have x equal to 100. Alright? So, keep in mind, basically, go through this process. There wasn't anything inside the radical except x, so they didn't have to get to that third part. But, on these problems, when you're solving, again, this is for solving radical equations, identify which side your x is on, okay, and focus your attention on that side. And then look for anything that's outside the square root. So go ahead, identify what's outside the square root, and then identify the opposite of what's going on with it. So that side, I noticed I was dividing by 5. So that the opposite of that would be multiplying by 5, which is how I knew how to get rid of it. I multiplied by 5 to get rid of it. So identify what's out there, do the opposite of what it's currently doing. Once everything on the outside is gone, then square your radical, and then focus on whatever was inside the radical that's left. Okay, that's going to be it for this video, guys. I hope it helps a little bit. We'll see you in the future when we cover complex numbers. Adios. Sayonara. Bye-bye.